on data analytics with Python. So please confirm if all of you are available.
Good afternoon, sir.
Good afternoon. You can just put it into the chat window, that will be fine. So I can start it. And everyone must have loaded that PUBG. One good option also has been one good option has been provided by, I think, who has provided. I will just copy paste his line. That is also good if you want to open it. Umesh Mai, Umesh Tatya Sahib Mai. So for Google Colab user, I will just copy paste his answer. That is also a good way to open the file. Okay, so I have just pasted it again. So that is also another way. So the data has to be loaded here, CSV file, that is sure. But you can open with file and open method with GitHub. Okay, where you can put the GitHub link. That is also possible. So hopefully all of you are there. So should we begin with? Or is there any? Okay, so let's jump to code. So I will going to explain the code one by one. What are the analysis? What are the codes we are using? The same is available to you. The current state which you can see is directly in run state. So you can just watch all the things and then you can run it afterward, or parallelly also you can run it. Okay, so let me go to the PUBG dataset. So the PUBG dataset, as I said, consists of multiple things which also you need to know from the columns which has been provided. Okay, so whatever the columns has been provided consists of the main thing, that is the killers, the runners, the drivers, swimmers, healers, solo duos, squad, correlation, and then the last one is the feature engine. So that is the way I have divided my code. So what I am trying to do, I will compare some of the important columns again that what I think are important. Okay, because even I don't play this game, but still from sources which I got the answer that these are the most important things where you should have. So like you can have a more kill, you should travel a more distance, and then you will have a more understanding of how your percentage can change. Okay, so that is the case. Voice is not correct. So what about others? Are they able to hear me properly? Yes. Okay. So those who are facing some problem, do reconnect or just check your net connection or refresh, because it is going fine for my side. Okay. So I think who asked the question? Hanumantra Bitra. So you just check your net connection or refresh the session, then you will have, I think, a proper voice. So as I said, these are the steps which we need to follow to understand how we can go ahead with the which columns which we will say we will utilize. We will analyze its correspondence with the final column, which is the win percentage. Okay. So before starting all this stuff, we need to read the files. Okay, so these are the steps which has to be done. Let me explain. Parallelly, you also can run it. Okay, so the first thing in this first cell is all the kind of packages like we have said previously, which we will require. Includes the NumPy, Pandas, Matplotlib, Seaborn, and warning package just to filter warnings ignore, because many times the packages changes, then there are deprecation error. So to avoid that, we will ignore that warning. Okay, just the warning, not the error. And whatever you see here as NP, as PD are actually alias name. Alias name what? any function inside NumPy when I want to use, I will not use NumPy dot, I will use np dot. That is the shortcut. Once you run this, you should wait for some time because running or loading of this library takes some time. Okay, so you should wait for some time. Then you read the CSV file directly into a variable called train. So this train variable will be a data type of data frame. Okay, so data frame is one of the data types which comes in library pandas. So this will be a data frame is nothing but an SQL table, you can say. Okay, just like an SQL table, you have multiple columns, rows. Same thing the data frame is, and I am reading it directly into read CSV. And just to confirm if I am able to read it correctly, I will use one of the function info, which provides me what kind of data I am reading. So it gives the column names which are available and its data type. String data types, alphanumeric, all are treated as object when it displayed. It is actually str data type, whereas other columns are integer and float. And that is the way how the data is provided. Then I will discuss what this data is. Okay, so let me know if you are able to run these 3 lines. Most of you who are running on Jupyter, it will read it fine. Memory error to read file in Jupyter? No. Now, what kind of memory error? So for Jupyter, those who are working on Jupyter, you are using Colab. Okay. So in Colab, once you run this, is it running fine? Means the import will run. Obviously, it should run because this is the file you have kept there, right? So this should run properly. It is running. Very good. Good. So those who got that memory error, if they are working on Jupyter Notebook, wherever your IPNB file is there, at the same place you keep this train underscore v2 file. Otherwise, you can pass the path also, but again, it is the slash or if it is a Linux, Mac, all that comes into picture. So the better way is wherever your IPNB file, like my IPNB file is this PUBG data analysis dot IPNB. It is under Anaconda project under notebook. Okay, in general users folder. So I have copied this also at the same place. So you do the same thing. If it is not means if it is giving memory error, this memory error should not be there. Memory, I don't know why memory is there. Maybe the location error or file not found. That may be the errors only. You can look at it. All of you are able to run up to this point. Any problem or anything you are facing? It's running. Okay. Good. So now once you run, these are the details as I said, which has been provided. So what are these details? The group ID and match ID are just the IDs, or you can say a unique numbers to identify which group you are belonging or which match you are playing. Then comes the important assist, that is the number of enemy players. These player damage that were killed by the teammates. Means it is just assisting a player, enemy while killing, while it has been killed by some other teammate, not him or her who is playing. Okay. Then there is a boost, that is just the, as the name suggests, it is, you can say, a kind of healing or health. Then damage dealt, that is the total damage dealt. Inflicted damage is subtracted. So if I am doing damage to myself by wrongly having a knife or a bullet, that will be negative. Otherwise, how much damage to an enemy I have done. DBNO is the number of enemy players knocked down. Okay, so that is the DBNO number. Knockdown means within a shot we have killed. Then there is headshot kills. Okay, so headshot kills talks about the kill with the headshots, as the name suggests. Heals again comes under the healing or the additional part. Kill place and kill points. Okay, with the kills and kill strikes. Okay, so these are the most important part which signifies how many people you are killing. Okay, so again it is not a good test game, but okay, let's have this for the analysis purpose. So it is a place where, because that ranking also matters. Some of the places in this game are difficult to enter or difficult to go there and kill somewhere. Some of the places are safe. You hide somewhere and you kill. Okay, that's why the kill place has the ranking. Kill points is the kill based external ranking of a player. It gives you the points, how much you have done. Whereas kills gives the number of players you killed. Okay. So So the lunch time is heavy. Then you have the kill streak, which is maximum number of enemy players killed in a short amount of time. So it will not be very useful parameter because it is varying very deeply. Okay. Longest kill is the longest distance between the player and player kill at the time of death. So actually, what is the distance between them? If it is nearby, very far, or you aim very well, what are the measures you have taken? Then max place is there. That is the worst placement we have data for in the max. And this is not actually used in our case. But revives will be used because it again consider how many revived teammates, because there is an option like I have suppose points and I can revive some of my friends. Again there is a limitation, but that is there. Similarly, you also can get revived by your teammate. Then there is a ride distance if you are having a vehicle, maybe a jeep, car, or a two-wheeler. Road kills while driving, how many kills you have because it is fast, so it has some less advantage. Swim distance, as I said, out of 3 to 4, they have different locations. Okay, so out of one location, no water is there, but for other location, water is there. Okay, so there, how much swimming distance? Team kills, number of times this player has killed the teammate wrongly. Okay, most probably you will do it wrongly, but that also counts. Vehicle destroyed also has a good analysis. That means if you start destroying the enemy's vehicles one by one, count increases. Walk distance, weapons acquired, what kind of weapons, maybe point. Win points and win place percentage. So these are the most important one. In that, win place percentage is the target of prediction. Okay, we are not going to apply machine learning, but that is our prediction. And for that, we have to make sure our data is ready to go ahead with. So this is the percentile winning placement where one corresponding to first place and everyone wants to go to that place, and zero corresponding to last place, and it is calculated off of the max place, not a number of groups. So it is possible to have missing chunks in the match. So that happens because of the group and solo thing, as I said in the start. So that kind of data is provided. Obviously, whenever you get any kind of data, at least you should have this knowledge. Maybe a person who is providing that data may provide that. Else, you may have to find out your own with some other online stuff. That what kind of data is this showing? Values are there, but in general, if it is a proper columns and rows, the data will be more clear. Okay, or if the data description has been provided by a domain expert who works in that industry. Now there is a function called train.head. What it does, it just shows the first 5 rows of total rows. How many total rows? Many rows are there. That count will be here. I think memory use. Okay, you may have that memory uses from here. If you don't have that many space, someone has got that memory uses. So nearly this many rows are there. It is 1, 2, 3, 4, 5, 6, 7. 7 entries are there. So that many rows are there. That is the range index. Okay. So huge rows are there. Very big rows. Nearly I can say 44 lakhs. Okay. So 44 to 45 lakhs of rows. That's why the data is heavy also. So that many rows are there. So out of that, if I want to just print the 5 rows, I can just have the head command. I can change this also, head in bracket any value like 3, 4, anything. So that many rows it will display. Okay. So this head generalize, why you use head? Generally, whenever you read the data, it is better to view that in a single go, how the data looks like. Once you have the confirmation how it looks like, then you can go ahead with that. Okay. So the data which has been shown and the columns which we have said, these columns will not signify anything, group ID, match ID. What will signify is assistant, boost, damage dealt, and so on. So many columns are there. Important is the last column, which shows out of from 0 to 1, what is the win place percentage. Okay, and that is the prediction we should make on the basis of this data if it is provided. Saying that if this data is there, what is the prediction, how much line of I can say that the person will win or not. Okay, so that is the case. So once we have this, we will start exploring, we will start doing the data analysis, we will start the visualization using the libraries which are directly available in your Python. Okay. So let me know if you are able to follow up to this point, because then the actual one by one area analysis we will start. Anyone, if any facing error, let me know, or we can proceed further. Whether you got the idea, good. What about others? And I think most of you are using Colab or maybe I can say Jupyter Notebook. And if not, I have said as .py is there, means you have to convert it into py file and then proceed. Okay. And in Colab, do remember once you load file, as I will show here, once you load file, it is temporary. Okay, so once you close this file is gone. Okay, it will not. This IPNB file will remain, but this file will be removed because it is a temporary storage provided. So that is the way you can have. So today's attendance has 11220 link. That is for I think all of you to mark your attendance. So do mark your attendance. It will be calculated. Right? Okay. So should we proceed or we have to mark it first?
No, sir, you continue. This they will mark. You
Okay,
proceed.
okay, I can continue. Okay, okay. So yes, Dr. Vidyut Deshpande. Yes, it's after disconnection the files are lost, so that has to be loaded. But the Colab file will remain. Means .ipynb file is there. That will remain there, and it is actually saved in your Google Drive. So you can just copy paste, download anything you can do. So the first thing is the killer. So what is the kill percentage and how to get the idea of that. So for that, the way of selecting a particular column from a data frame is this. You put the data frame name which was train and the square bracket stands for indexing the column. So train.kills actually selects what? The kills column with how many values in that? Same 44 lakhs. Okay, because that is the number of rows we have. On this, if I apply .mean, it calculates the mean value of fields. Okay, and then this is just the kind of formatting I have added. Even I can write simply print train fields mean. That also gives the same result. It is just the decoration. So it gives the average value of filling is 0.9248 depending on what values we have. So if we see the fields column, where it is not shown here, or it is there. If the number of columns are much more, it will not show in the head command. So in that case, you add a print command here like this. You put print in bracket head. Then all the columns will be shown. Okay. So that also you can try it out. So there will be a kill option where the value will be there. So its average is 0.92. If I want to see the quantile, what is quantile? You must have heard this from the previous math section. Like we generally deal with Q1, Q2, and Q3 quantiles. So they are nothing but the percentile, you can say. Okay, so Q1 stands for what? The 25% of data will be below that value, 75% data will be above. Q2 stands for your median and Q3 stands for your 75%. Similarly, when I use the quantile 0.99, I am talking about 99 percentile. Okay, so the keys contain 99 percentile. So how many people are there above that level? So it comes out to be 99 of the people have 7.00 kills or less. Okay, so that are the percentage I have calculated. So most of them have 70.0 or 7 kills. And if I want to find out one row which has the max killing, it comes out to be 72. So one row which has killed 72%, which is very huge. Because in actual game itself, 100 people are there playing with each other or killing. So as a single person, if he or she has killed 72, very max value. Okay. In this program or even in this PUBG, there are some other ways also. Maybe I can say the hack or something which you can directly reach to some level, or you put some hack code and you will have some power or something. So that may also happen. Means even if we are looking it in a proper way, these illegal ways will be there, and we will find out some cases that person haven't moved from the place and still has killed many people or still has achieved the first rank. Okay, so that may happen. So the data is you can say cheat code. Yes, that was the word I was looking. I forgot. Yes, that is correct. Thank you. Prabhaharan. Okay, so that is a cheat code. So that cheat code data, if you apply, you have different things. You may won also if you have a cheat code. So this 44 lakh data have some players which has been entered with cheat code. Okay, so when we cannot find out that, means we can find out also, but that will be some different logic to apply. But let's have not in that direction. But you should remember that may happen. So like this 72, I can say that that is coming from some cheat code or something, because 72 is very high in my sense. Now to analyze or to plot this data, we are using the SNS, that is what a Seaborn library, for which we have given SNS as a alias name, and its count plot. So as the name suggests, count plot generally counts number of occurrences or the number of rows in your data frame. So for that, what I am doing, for the data LOC data keys greater than data keys quantile 99, I am putting it as 8 plus. Why? Because after 8 or after 8 plus, there are very few records, means maybe 100 out of maybe 100 or less than that sometimes. So for everyone, if we want to put bar plot, they will be very small. So instead of that, what I want to do, I will combine all the keys above 8 as a single column, okay, as a single entity. So how I can do that? Now this is where the Python, you can say the Pythonic way of doing that. What we are doing is the data, which I am doing train copy. What happens when I do train copy? Train is actually our data frame. Data will be a new data frame created, a virtual copy of this. If you make changes in this data, it will not affect train. Train means the actual data frame remains as it is. Okay, so it will not change. So I will put that whole data frame into a new data frame. I cannot do directly. If you think like this, I write data is equal to train. So there are again two ways to remember, which is called shallow copy and deep copy. So here comes attendance. So, so you just scroll backwards, you will have the attendance for Maresh Rao. Okay. Here it comes again. So keep rotating that. So those who join for only attendance, they can have their attendance. So what I was saying. So this, if I write only this statement, data is equal to train, it will not make a copy. In actual, both the variables will point to a same data frame. So any changes in data will reflect in train. So we don't want that. So that is the way dot copy has come into the picture. In that, .loc stands for particular row. In data frame, the preference is on columns, so the particular row can be accounted for using LOC or the location functionality. In which, what I am saying, wherever the data kills is greater than data kills quantile, which is actually 7, okay, which we have seen here, right? So I can put the directly value 7 also, but I am making it more generic. So whenever the value is greater than 7, put its value as 8 plus. That means wherever the keys is more than 7, maybe 8, 9, 10 up to 72, all these values will be changed to 8 plus. So I will have all the keys as 1, 2, 3, 4, 5, 6, 7 and 8 plus. Now the other remaining thing is just the plotting thing. So I am putting a plot using a PLT functionality. What is this PLT? PLT is coming from matplotlib. That is another visualization library which creates a outer boundary, okay, for your graph. So again, since the topics are very large, I need to go with the specific detail of whatever we are using. Okay, we cannot have a detail because again it will be a big course to do this data. And then we are applying the count plot on what? Data keys column, the same column where we have converted it into 8 plus with the conversion of string. And before sending it directly, I am putting a sort values on that. What happens? Sort values are putting, the data will be sorted first in an ascending order. That means lowest values will come on this side, highest value will go on this side, and then the count will apply with the title kill count. So kill count title has been provided and data is applied here. So what kind of graph it shows? There are many rows. So I can say it is 25 lakh rows where the kill ratio is 0 out of 44 lakh. Then there are few more rows like 1 lakh or 50,000. I am counting correct. No, this is 5 lakh. Okay, so it is more than that. Okay, It is not 5 lakh. It is 2.5 lakh maybe, or 25 lakh. 25 lakh is the target. So correct. So nearly 5 lakh to 10 lakh rows are there for 1 and 2. So there are most of the people or most of the players who have killed 1 or 2. And then it starts decreasing. Okay, going for 6, 7, and then 8 plus very few. Okay, not to be made. Because if I don't put 8 plus, it will be 7, then 8, 9, up to 72 with a very fraction of line, because there may be a 1-2% only. That's why we have combined. Now this gives that most people can't make a single kill, at least they do damage. So from this graph, and whenever we plot the graph, the actual visualization thesis or whenever you do it, the main theme is you should capture the understanding or the inference through that. What that graph shows, what that graph tells you, what graph gives the inference to you, that is important. Okay, then only you can understand, okay, what the way we can go ahead with. So this graph gives the inference. There are many, nearly 25 lakhs rows which don't have any kills or very less kills. So I will go for the next step, because I need to find out the percentage of win. So if the kill is not there, I will say let's see at least doing a damage, maybe a damage to a vehicle or some other enemy. Can we get the winning percentage? Okay, so that has to be done with the kills 0 only with the damage. So how we will do? I will put the data with the data kills is equal to 0. Again by doing train.copy. What happens in these steps? Data will have only the rows where kills are 0. So now I am filtering out the data. So this is a filtering process we are doing. You got the idea? And this condition putting inside a square bracket is called Boolean indexing. Okay, so that is one of the indexing type one can utilize. Okay. So once I put the Boolean indexing and I have fetched the data will not have any row with fields more than 0. So all of them will be 0. And that data I am plotting with another plot called distribution plot. So previous was what? Count plot. It was just counting the number of rows. Whereas distribution plot is something similar to our histogram, which again goes for the frequency distribution on what? Damage dealt. So if I go on frequency distribution of damage dealt, and this line is what called KDE, like what is it long form? Kernel density function, or kernel density expression or something. Okay, so that KDE will come out of that. So what this KDE shows, again the damage dealt is increasing at some point of value. Okay, so but otherwise it is again at 0 level, and these all are from which case? Where the kills are 0. Okay, not for other. For others, as the kills increases, we may have more chances to win. That is our assumption. So once we have this data, we get the idea that most of them don't. That means they are not doing a damage, they are not doing the killing also. So let's move for the exception, which are these. Okay, so the players have won without a single kill. So if I want to find out the number of players who have won without a single kill, means they were just sitting or hiding, whatever. How I can get? I will get for the data, because data is the one where all the kills 0 we have put in. Okay, and I am saying win percentage or the win place percentage is 1. So out of whole data, I get 166 or 16,066 players who have won without a single kill. So as I said, cheat code. So they must have some cheat code or something. Maybe they can vanish also, or there are so many things. Okay, I haven't seen the cheat code for vanishing, or is it there? Any one of you who play this game? So if they may be the case, they may vanish and then come back when everyone is dead. Okay, so that may be the case. So these are the players who don't have done any heal or the damage. And if I get the damage dealt, so the players that have won without dealing the damage, how I am calculating that? In the data, what is the win percentage? If it is 1, okay, so that I am putting with damage data 0. Okay, so for that I am using another data field, data 1. So there are 477, that is 4,770 players that won without dealing the damage. So they are also there. So the way we understand that there are the cheat codes that have been shown here. Now we can use the plot which will use for understanding how there is a relation between winning place percentage and the kills. So how we can do that? We use another plot from SNS called joint plot. So joint plot, as the name suggests, for two columns it will be used. So it is the win place percentage column and the keys column coming from the trend data. Other parameter is like a height, ratio, color, and there are many parameters. You can check any parameters for any detail by using help command. Okay, so that is also possible. So if I plot it, this is the plot which gives us the winning percentage starting from 0 to 1, and these are the number of kills. And obviously you can see the trend is here, more trend is here. That means as the number of kills increases, the chances of having, and you can see from here also, means even if I draw a line here, all the percentage of winning has increased. Okay, means here are the kills. So as the kills increases, the percentage of winning is there. There is an exception which can see here, and they are most of them the cheat code user. Okay, otherwise the data is proper increasing with the increase in the kills. Okay, so apparently killing has a correlation with winning. Finally, let's group players based on fields like 0 kills, 1 to 2 kills, 3 5. So the groups I want to create. So group can be created using one of the interesting function called cut. So cut actually cuts your column or the values into particular groups and also labels them with some values if you are passing some label. So I am giving the labels as 0 underscore fields, 1 underscore fields and so on. And I am cutting what fields on what axis -1, 0, 2, 5, 10 and 6. So once I put this cut, what will happen? Fields categories is the new column which we are creating. And we are plotting it with another kind of graph which is called box plot. So box plot is generally what? It shows in a box plot a max value, a mean value, a median, a Q2 and Q3. These are the values it will show. And then we have plotted the box plot on basis of what? Same win percentage. And way how all the graphs are going upside shows that as the number of kills increases, the percentage of winning is also there. So this is the inference which we have drawn after doing the EDA or the data analysis on a single column field and also a parallel column damage, so we can have the understanding. And we come up with the result which shows that kills ratio or the killing ratio has a directly proportional to winning a game. Okay, so that is the first observation we will make, and we will make sure whenever we apply a machine learning algorithm, we will use this column because it will apply large. So everyone got this idea up to this point? Any question or error? All of you are following? Okay. Yes, Silverthi, any problem? You can put in the question here. Oh, so yes sir and no sir both is coming. So it may be some other. What are the subplots? Okay, subplots are generally used like have we used the subplot here? I think no. But I will explain. So like here I have created a figure of 15 by 8. Okay. So the question was Sanju Kumar. So the subplot is instead of this graph, if I want a grid, say 4 graphs, 1, 2, 3, 4. So that 4 graphs becomes the subplot. So for each subplot, a variable or the axis variable has to be created and each graph has to be passed with the value. So that is called subplot. And as the name suggests, means for this subplot is the method, and you can call it to have a particular plot at particular place. So that is the subplot. It is available in Matplotlib and Seaborn. I don't think subplot is there, but Matplotlib definitely have the subplot. What the idea, Sanjeev? Sanjeev, you got the idea? Or no, no, Sanjeev only asked. Sanjeev Kumar? Okay. So let's proceed further. The next thing comes is under the runner, because as the space is vast, you have to run from one end to another to may get the heal power, or you may have to kill someone which is coming in between. So for that also we had added some common analysis. So for next 2-3 columns, we will utilize same methods, okay, and then we will have some another methods to add new columns, which may be a combination of 3 more columns. Because that is also sometimes required. I think for tomorrow you have that dimensionality reduction. What that dimensionality reduction is the same, reducing the number of columns. Okay, so it is a kind of clustering only, whereas clustering is divided in 2 types. Like k-means for row-wise clustering and PCA another method for column-wise clustering, where I can combine the column so that the effect will be same, but still I have the less column to utilize. Okay. So what are the different methods to handle null values in the column? Okay, I have to scroll down. So the null values are shown as nan values in Python, NaN, and there are methods to handle that nan values called drop NA, fill NA, and replace. Okay, so these are the 3 methods which you can utilize to deal with the nan. So as the name suggested, drop NA will drop a complete row or complete column if it has any single nan value, which is not advisable. Obviously, you will not lose all the other data just for one missing data. Whereas fill NA is useful because it is used to fill the values, any values 0, 1, 2, 3, ABCD into nan values. So fill NA is useful. The third one which I said is the replace. Okay, so that replace works with nan and other values also, outliner. Like if I want to replace any value which is 50 with 21, so I will just use the replace. So these are the 3 methods of pandas data frame which can be used for handling the null value. Okay. You got the idea? Who asked that? Vikala Girish Kumar. You got the idea? Okay, good. So now let's have a look on the distance traveled by barefoot. Okay, or not the barefoot, barefoot. So for it also we have the mean, quantile and the max value. So you can see max is 25,000 meter. Again in meter it has been provided. The max value traveled. Average is generalized 1000 or 1154, and 99% of people have walked 4396 meter or less, not more than that. Okay. So these are the values are available. So again here we will put quantile as the lower age rather than having remaining bar chart, and put a title on that and use the distribution plot again. On what? Walk distance. So when I write something like this, it is working on this column. And this column will be utilized to get the output. Okay. So once I do that, I get this graph. Again, it shows that most of them are traveling at some distances, so that they have a good win of percentage. Okay, so this is actually not compared with win of percentage, how the walk distance is divided or distributed. So there are others also who comes or who have traveled some distance. So the means that they die before even taking a step. So there are some places, means what happens once you appear on the game, there are the chances 2-3 people are already there, considering you will appear there, and they start killing. So that also happens in the game. So in that case, there are 99,000 rows who don't have walked anything but died. Okay, so they have 0 marks. So again, we will have the walk distance with the win place percentage under the joint plot. And this plot again shows the increase in the percentage of win because walking more distance. So the walking distance vital column which can be utilized to have the thing. So as someone has asked which columns to be selected, these are the columns I am taking randomly. Why I am taking randomly? just to think that this may affect my output. Okay, so again, it is up to you which column you have to utilize or not, because you may come up with another column in this data frame, and that may be also an important column. So we cannot deny that. Okay, so this column or other columns are also important. The next thing is, so that is the walking has a high correlation with the winning percentage. Then comes the drivers, where we can apply the vehicle or bike or anything. So for that also I have selected all three. Now I have put it together. So 606 is the average distance traveled. 6966 is the 99 percentile of the people. And the Formula One champion or who has driven much faster or much places is 40,000. So for that again I am putting a distance with quantile 91 and I am putting here the value. For each cases there are the zero traveler or who don't got any vehicle in hand. And for these cases 33 lakh, which is very high value, okay, who haven't driven. So if we have put the win place percentage, the statement gives the same idea. As the ride distance increases, the win percentage, and you can see the spread. Okay, so as the ride distance is, there are good chances of winning the game. But there are the small cases which we can say we have the relation with. So we can combine this ride distance with walk distance. So we can have a common distance traveled. Okay, so it may be from different columns, but that will be important. Second thing is destroying a vehicle, because destroying any kind of vehicle also plays an important part. So for that I am using a point plot, because destroying vehicle has a very specific value 1, 2, 3, 4. That's why. So vehicle destroyer with the win percentage, and I am plotting with the color. So you can see here in Seaborn and even in Matplotlib, you can provide the hex number of colors. Okay, so the hex number of colors means every colors you can provide as a hex code. Okay, so that is also there. So that also gives a good idea. If you are working with some web development or know about the HTML, you must have having this knowledge of different hex color for different color shades. With the X label, Y label, title and the grid and show, once I run it together, I get a point plot. What is this point plot? Vehicle destroyed 1, 0, 1, 2, 3 and 4. And you can see the win percentage will got increase in this range with more and more points on this line 3. So most of them who have the good percentage has destroyed a good percentage of vehicles also. Okay. So destroying a single vehicle increases your chances of winning rapidly. This from 0 to 1, you have just jumped from point 4 to point 7. So rapidly it can increase. Then get the swimmers. So for swimmers also we have the same output which we have tried, and we have put in the data, but there is very few data. So as I said, there are 4 categories. In one of the categories there is no swimming option. So it may be the case swim distance may not signify much of the winning percentage. And even I plot it on this plot, the most of the values falls under 0, because we can see from this histogram. So this may show box plot of winning percentage, but the number of values in this tree are less depending on this diagram. So that doesn't add something. Healers does add. Okay, so as I said, there are healers of boost available. So we will see heals and boost in the percentage. Okay, so I am showing here in the percentage. And on this percentage, if I want to use the same percentile method, and I have plotted it. And the graph shows as my heals or number of goods atoms increases, the chances are good I will have the good percentage. Whereas in downside, like the boost, it is definitely increases. Heals sometimes may not have a positive effect, and this may be because heals is used when you are have lot of damages to yourself. Okay, so it may be the case even if your heals are increasing, that means you need a more or you are experiencing more damage. On plotting with the joint plot, it gives a good combination on this side, so showing that percentage is going to increase. Same thing happens with the boost. So boost also have specific values, that's why a particular line appears. So healing and boosting definitely are correlated with win plus percentage. Out of that, boosting is more correlated rather than the healing power. Now, in every plot, there is an abnormal player when values are zeros. Okay, so we need to think of how many players are playing also, because that also defines what will be the percentage. Why? Because if there are less players, obviously the less chances of kills and all things happen. So the percentage should change. Sorry. So for that, there are three game modes in the game, as I said in the start also. The one is the solo, the another is the duo, and the third is the three other friends. Okay, and that is called the squad. And it is allowed 100 players to join the same server. And there are multiple server or multiple clones which will be running. You can join any one of them. So, so when we say there is a limitation, you can have the duos that are maximum 50 because 100 by 2. And when I go for the squad, maximum is 25. So that kind of columns I am creating here, the solos, duos and squad with the condition number of groups. So that is actually counting the number of groups, maybe solo, duo or whatever. So whenever number of groups are more than 50, all data goes to solo. Okay, that means there are solos only. When it goes to duos, the number of groups between 50 and 25. And if the groups are less than 25, we go for the squad. Okay, that is the group information provided. And then we have plotted again the length of solos, duos and squad in our game. Now this plot is actually the plot of win plus percentage with the kills for solos, for duos and for squads separately. Okay, and as the plot is shown, different colors also has been used. Already all the plot shows as the percentage increases for all number of kills, but the variation is different for solos, for squads and others. And obviously in squad, number of kills will increase because many groups, like 4 of you are killing, so obviously the count will increase. So the same thing is written here. Solos and duos have the same, but when playing squad, kills don't matter that much, okay, because it is going in the rough direction, up and down. So the attribute dbneom is enemy plays knock. A knock can happen only in duos as squad because the teammates have the chance to revive the knock player in the given time. So the knock player can be revived or died. So for that, what I will do again, attribute revive I will add. Okay, so every time I am adding new column, knowing what is the use of that column in my game. Okay, so when I apply it, you can see another graph appear with assist, DBO and revive. Okay, so that is also an important point to be added. So when you want to do the analysis of all the columns, or you have to come up with which columns has a good correlation or Pearson correlation we call it, there is another method called correlation directly available in data. You don't have to do any call or something. So trend.correlation will calculate all the correlation values between all the columns. Okay. And then it can be put in heat map, which actually have the diagonal of 1.0 because 100% correlation of column with itself with other values here. Okay. So the positive correlation or the negative correlation. So from here also, those values are more than 0.5, positive side, negative side, also can be used or compared for the column. Okay, so that may be another way to identify if the column is important or not. So hopefully everyone is following this, or maybe lunch is heavy or something. The covariance is also useful. So the function for covariance is COV there available. The difference is the correlation is generally between -1 to 1. So it gives a very clear-cut idea if the positive correlated or negative correlated or in between. Whereas the covariance is actually the value how much variance will happen. Okay. So generally if you took out the formula, the covariance is what? It is the summation of actual value minus mean value for x and y and divided by the n minus 1. Whereas the correlation comes out to be what value? It is the covariance divided by standard deviation of x and standard deviation of y. So it reduces it or normalizes the value. So it is better to use correlation that rather than covariance. You can apply covariance in the same fashion. Means instead of correlation, there is COV function. So that will also give the result. Only these values will be actual movement. That means 0.008 or 0.009 or minus 0.00003. So that gives the how much change may happen. Okay. Whereas this shows how much relation is there. Okay. So going ahead of this, now out of showing all of this, let's zoom for the top values only. Okay, so that will be more better for us. So here some complicated complex thing I had added. You may not have all the idea. N largest is the function which will select the largest value from this. Okay, so that is only you keep in mind. So if I have only 5 of values out of this, I am putting that in CM and using the heat map. It gives me the idea that there is a win place percentage, walk distance, boost, weapon acquired, and damage dealt. So these are the different or the most important points which has a very good correlation as 0.5, 0.64. So like if you said which columns are more important, these columns may give you an idea that these columns are more important or more correlated. So let's plot the above variables and the kill place variable as pairs. So pair plot is something like each variable or like here I have this many columns. Okay, so you consider them in this pattern. They are on x and y axis both. So they are on y axis here and on the same line on x axis. So if I consider this graph, it is a relation between winning percentage with kill place. And these are the dots mean these are the values we have. This graph is the weapons acquired related to kill place. So you can see the most of the time zero values means there is less relation. Even if kill places increases, the weapons acquired may not increase. That is the showing of this value. Whereas if I just go above this and this, both graphs will be same. Only thing here damage dealt is on x-axis, whereas here damage dealt will be on y-axis. And below that you will have the values which comes from here as a kill place, whereas here it is a kill place. So it is a kind of diagonal matrix which will be created. All the output or the values if you see, they are the elements of the diagonal matrix. In this diagonal matrix, whatever comes under the diagonal is actually a histogram. So if I just show the last one, this is kill place from this side and this side. So this is just the values frequency distribution which has been plotted here. So all the diagonal elements which you can see here are nothing but the histogram. Whereas this are the joint plot from seaborne point of view. And they are appearing points. So that means lower triangle or upper triangle will be sufficient to analyze that data. Okay. In the subplot here, you mention 11. Here I mention 11. Encoding. No, this 11 by 11 is actually a figure size. How you will explain this? Okay, so this figure size is this size. 11 by 11 are like 18. They are not a subplot. Subplot is something like here 15 by 15. This is the figure size I am mentioning. That is not a subplot. Means 11 rows and 11 columns. That is not the case. Okay, so that may not be confused. Subplot is a separate thing. Means it is not here. Even if I am putting subplots here, the figure is single one, not the multiple plots I am putting. So that is different things. Means don't consider this will be 11 because obviously it is 1, 2, 3, 4, 5 only, and on the same line 5. So it is not okay. So if you want subplot example, you can have it separately, like where you pass the plot subplot and then utilize in the for loop or something. So you can have say one plot, second plot. The subplot may look like this. Means if I consider this 4, this may be a subplot 0, 0, 0, 1, 1, 0 and 1, 1. and then it will show the graph. This may be the case. Okay, but that is not the subplot method there. Okay, so don't get confused there for Sanjeev Kumar. So the pair plot has given us the idea where the joint plot has been plotted. So all these are the joint plot, whereas this diagonal are the histogram. Okay, so that is the way the data has been shown. Now, if I go on feature engineering, which will be the last part in our this case, the game PUBG can have up to 100 players, okay, fighting each other, but most of the times the game isn't full, so there is no variable that uses the number of players joined. So that also we can calculate it from the match ID, because match ID will be common. Okay, so we are grouping the data on match ID and we are putting a count. So if the player join is more greater than 49, we are plotting it, and this is the graph we show. At some places player joins, and at some places the player joinings are higher, like 91 or 92. So based on the player join feature, we can create a lot of others to normalize the variable. What happens when the more players are joining, the game is more dangerous or more tricky. So winning between 96 has more win percentage, right? Rather than winning between 60 or 5 or 7 people only. So that can be done with the normalization method like this. Now this is my own normalization. It is not we do the actual normalization. Okay, so how I have done my normalization? When there are 100 players in the game, it might be easier to find and kill someone because 100 players are roaming around. Then when there are 90 players, so their percentage has to be changed. So how we will change the kill percentage score? 100 players will score 1. As for 90 players, I will do 100 minus 90 by 100 plus 1. So it will be more advantageous. So the less the player, difficult to find them and kill them. Okay, so the percentage has been changed. So I am adding a new column, kills norm, damage dealt norm into my train data set with the same functionality or same method which we have said here. So these are the columns we have added additionally to our data frame or our train data frame. Similarly, we can combine some of the columns like fields and boots. We can combine both of them together because it asks about the same thing. Distance can be a combination of walk distance, ride distance, swim distance, because some of the platforms swimming is not there. So once we do that, we will again normalize that data on the basis of what we have saved. Okay, and once we normalize, these are the new columns which are added to the data frame which we have. Now we will have a feature kills per walk distance. That is how much kill we have done per walking. So that is also added in the part, because as you walk more, the killing chances are more. So zero walking distance and many kills also most have the win plus one. Definitely the cheaters. Okay, so that are the cases where this happening. They are the cheat code users. Okay. So once we do that, we also said there are solos, duos, and squads, and these columns were not available there. So we will add that column as a team. Okay, so that also added at the last. Okay, so that column is added as a team column. So to 2, 4, or this means if I is greater than 50, we are putting 1, that is a solo players, dual or squad player. So once we do that, at this place, we have created a complete feature engineering data or the data set through the EDA analysis, which we have been utilizing. And now these columns, out of this, most of the columns which added as a new column will be the most useful one to apply the techniques of data analysis on predicting what will be the winning percentage. Because other columns may not signify that much because we have seen that, and that's why we will go with that. So while doing all this kind of code, what we have seen, there are plenty of, I can say, libraries available in Python. Again, we have just touched the basic of them. Plenty of methods are there. Again, in a single hour or 2 hours, we cannot learn pandas as a library. Because when I teach, it is nearly takes a week for me. Because it has multiple things to analyze, multiple functions to apply. But this gives you a glimpse or the idea how I can analyze the data using the pandas library and the visualization. The process further continues, which will be done with your other FTP session, how we can use this data for machine learning and prediction and data dimensional reduction and all. Okay. So that is the part from my side. Any question up till now? Whatever the points we have covered. And if you want to run this again and again, we have an additional thing, that is our YouTube channel is also there. So I will just share that link where I have loaded the whole video of this, what we have discussed today. So do check this YouTube channel also, or subscribe, comments on that, because we are having lot of new things in that YouTube video. Other things like teachable machines and then speech to tweet recognition, so many things I have added, and every time whenever I do some lecture on any college, I prefer a new topic like Raspberry Pi and all that thing. So all things are come up there day by day. Okay. Even interview hack are there, program logics are there, many things are there. So do connect with YouTube channel and do subscribe there. Okay. Yes. Is hyperparameter tuning comes under? No, 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 no. It will not come under feature engineering. Now it is a kind of loop, you can say. Means once you proceed with this to your machine learning, you will come up with the result. So to have a good result of your machine learning algorithm, you have to tune your hyperparameter. Sometime after tuning hyperparameter also you may not have a proper result. So again you have to come back to feature engineering, which we have done, to have some columns has to be added or some columns has to be removed. So in direct, we don't have any connection between hyperparameter and this feature engineering. Okay, but it may come back to the feature engineering if hyperparameter is not working or their tuning is not proper. Okay, you got the idea, Girish Kumar? So any other questions from anyone?
If having any doubts, you can ask.
Yeah. So after that, stress buster is there, right? Something.
Yes, yes, yes.
You have to review with your stress. What max size of data can we use? Colab, I think, just if you check, I think 120 GB is the size provided. I didn't remember. You just check it again. If I go here and you just put the cursor, it provides the, it is connecting. So it provides that, no, but this is your RAM size. It is still initialized. I think 100 or 150 GB is there. So if you check here, disk space is 107 plus 31, 140 GB at least. Can you see my screen? Who has asked that question? Bishwas, M. Bishwas. If you just put your cursor, it shows you the disk space. So for Colab, and again it is reusable disk space. Means if you are using right now, it will be there. Once you close your Colab, all the things are gone. So it is better to keep a backup or keep it in your Google Drive or something. Okay. So that is for M. Bishwas. And for Madeka, first way is tune the hyperparameter. Then after we need to go for feature engineering. No, means see the steps as I said. What we have done is descriptive analytics. Then you will have the machine learning algorithms which you will apply. Their hyperparameter will appear. Till now, the hyperparameter will not be in a picture. After not getting a desired result, you need to tune that hyperparameter. And after tuning also, if you don't get the desired result, then you have to fall back to feature engineering. So hyperparameter will not come first. Feature engineering will be always first. But it has to be done again and again if the proper results are not captured. So don't get confused with that. Always remember hyperparameter means nothing but the variables in your machine learning algorithm. That is the easiest way to remember them. Otherwise, it always creates some hype that hyperparameter is something and I don't have an idea. So you have the idea. Like in regression, the equation is y is equal to mx plus b. So it is a simple line equation. But m and b, which is a slope and intercept to a line, is a hyperparameter. So saying that as a hyperparameter creates hype, but it is a simple m and b. So don't get bothered with that hyperparameter. Okay. That is for Mekala, Girish Kumar. So hope everyone has enjoyed. So again, just copy pasting my link for your. Oh, there are no. Sorry, I just didn't go down. How do we detect? For outliner detection, there is the pandas methods or even the graphs also detects the outliners. Okay, means if you plot some kind of scatter plot, you may have the outliners there, or even the box plot. If you use, there are the quantile methods to remove that outliner. Okay, so that is also there. How is VAX compared with pandas? VAX I haven't used. What is that? VAEX? Vishwas? No, I don't have idea about it. What is that way? I haven't used that way thing. Oh, for large point. No, I haven't utilized. So I may not be able to answer that question. Right. Okay. Still, I will search. So that is the new thing. So every time means for me also, whenever I get something new, I always search for that because that is also useful for me. Okay. So thanks for all of you for joining this session and hope you all of you has enjoyed that. And as I said that you can utilize this in the videos also which has been provided in the same way. And it was again a very short time. You have to cover so many things. So we have divided in some part and as per my knowledge I tried to show you. Okay. So thank you very much. Still questions are there, but I think I have to stop here. Right, sir? Yes.
Yes, yes, yes.
So thank you.
Participant, if you are having any questions, so you can directly write to the Kelkar sir. He will definitely help you and sort out your problems. So
Yes,
at this point, I give thanks to Kelkar sir that he has very short notice. He has accepted our invitation and presented informative lecture at this workshop. So thank you very much, sir.
Thank you.
So participant, we will have a 5 minutes break and then we will going to start the next session, which is on stress management. So the sir who will going to take this session, he has already joined. So just for 5 minutes and then we will start the next session on stress management.
Sir, till the time, can you give us presentation access so we can check the PPT?